Hello everyone, I am Yashoda from LNVDI Japanese IT University. So, in my last video, I have given you a small introduction to data structures and algorithms. So, as you know, data structures are divided into two types called linear data structures and nonlinear data structures. So, in this video, I am going to discuss about queues, which is a linear data structure. Let's dive in. Queue is a linear data structure that follows first in first out method. It is one directional. When one end removes the data, the other end inputs data. Types of queues include FIFO queue, which is open from both ends like a normal queue, circular queue where the last element is connected to the first element, and stack queues, which is a combination of stacks and queues. In real life, queues are used in keyboard typing, CPU process scheduling, network packet queuing, message queues, print queues, and disk scheduling algorithms. Basic queue operations are dequeue, enqueue, peak, is full, and is empty.
Now let's see how to implement a queue using arrays in Java. I have this class called queue.java. And inside the class, I have 5 separate functions called enqueue, dequeue, is empty, is full, and peak to do the queue operations. Let's see how each of these operations are done. Before going in detail into the functions, let me first focus on these 4 variables. There are 4 separate variables here I have taken called front, rear, array q, which is an empty integer array, and n. So front and rear is used to keep a track of start and end of the queue, and n is used to store the array length. So before the enqueue and dequeue functions, let me first explain about the isEmpty and isFull functions. As you already know, this isEmpty and isFull functions are used to check whether the queue is completely empty or completely full. So if we take this isEmpty function, it checks whether the queue is completely empty without any element. So here we have checked it using an if condition. If the front and rear variables are equal to the -1 both at the same time, it means it returns true, which means the queue is empty. You can see here we have initialized these front and rear variables to -1. This indicates that the queue doesn't have a single element inside it, which means it is empty. Now we have this isFull function. isFull function checks whether the queue is completely full, which means that it doesn't have space anymore to insert or enqueue a new element. So we check whether the rear is equal to n-1. n-1 means if it is equal to the array length -1, which means the last element. So if the condition is true, then it returns true, and also it prints out a message called the array is full, and otherwise the function returns false. So that's how isFull function works. Now let's see how the enqueue operation works. I have this method called enqueue where I take an integer called x as parameter. Inside the method, we are first checking if the queue is full using isFull method. Because if the queue is full, we cannot execute the enqueue operation. If the queue is full, the enqueue operation is not executed. Then we go to check if the array is completely empty using isEmpty method. this is a special case. Since the queue is completely empty, the front and the rear will both be the same element and the only element in the queue. Therefore, the front and rear will both be the 0th element. And then we make the rear index of the array queue equal to the enqueued element here. And as the elements are inserted to the queue from the end of the queue, and then we print the element we just enqueued. In the else part, we consider the situation where the queue is not completely full or completely empty. In such case, we just have to increase the rear index and insert the element to that index. And that is how the enqueue operation works. Now let's see how the dequeue operation works. Hey to, my method name is dequeue, and inside the method we are first checking if the queue is empty using the isEmpty method. Because if the queue is empty, then there is nothing to dequeue. If the queue is empty, it will print a message called canDelete. Then we go to the else if part, where we check if the front is equal to the rear. See? This could only mean one thing, and that is the queue only has one element. If that element is removed, the queue will become empty. Therefore, if this condition returns true, then we set the front and rear to -1 again. Then we go to the else part. This means the array is not empty or array has more than one element. If that's the case, then the front element will be dequeued and the remaining elements will be shifted to left by 1 position. It's done by reducing the index value by 1 in each of the element. And the rear will be reduced by 1 after that. See, and that's how the dequeue method works. Now, last but not least, let's see how the peek operation works. As you already know, the peek operation returns the front value, which means the value that would first dequeue itself if the dequeue operation executes. So, first of all, in the peek operation, it checks whether the queue is empty, because otherwise if the queue is empty, then there is nothing to return as the front value. So if the queue is empty, then the operation or the method prints a message called nothing to peek, since the queue is empty. Or otherwise, else the queue or the operation will simply return the front value available. That's how the peek operation works. Now let's see how these queue operations are working. I have a main Java class called queueImplement, and inside the main method, I have made an object called queue using this queue Java class, and using that object, I have passed the enqueue operation 5 times, just like this, and here I have displayed the queue. So if I run this thing, you will see that these 5 numbers have been enqueued to the queue, and the queue is displayed just like this. So now I am going to use the peek operation here. Queue dot peek, and then I will be running this again. And there you go. By implementing the peek operation, I have returned the front value, which is 7. So now I'm going to use the dequeue operation to remove the front. I'm going to save this and run this again. So here, as you can see, the 7 was our front and the 7 got dequeued. And if I display the queue again, you will see that the front is now removed. So that is how our queue operations are working.
So that is all about FIFO queues. In my next video, I am hoping to discuss about trees, which is a non-linear data structure. So see you in my next video. Bye.